Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of pointers in structures. So I would like to make some pointers to structures. So before I start the discussion, I have to include the main package on the first line of the program. And also I have to import the fmt package so that I'm able to use the printline function coming from this package. Okay. And now let us go to the discussion of the pointer to structures. So what is a pointer to a structure? It means that the pointers can allow us to modify the original structure value if I want to make a pointer to a structure instance. So suppose I now have this kind of structure here. I have a simple person structure with the name and age as the fields. And then if I want to use a pointer to denote the particular instance called person here, I can use an ampersand to denote the pointer to this person instance. Okay, so I have a pointer to a structure instance, and I would be able to include the field values coming from this person instance. Okay, so if I want to print out the person pointer here, I'm able to see the address of this person instance in the memory. Okay, and after I have got the person pointer here, I'm able to see the name and age corresponding to this particular instance. So I can use the pointer to structure instance to really access the fields. Okay, so person pointer.age and person pointer.name can help me to show the content of this particular person instance. And actually, when I use the pointer to denote the fields, it is actually equivalent to doing the dereferencing first. So the above two ways are just equivalent to this one. I dereference the pointer first, and then I take the instance directly, and then I take the field of that instance. So I can use the pointer alone without any dereferencing to get the instance fields directly in Go language. Okay, so let me try to play with these lines of code for now. Okay, you can see that I'm able to get the address here. So this address is just referring to the person instance that has the name called Peter and the age that is 30. Okay, so this is the address. Okay, and the person pointer.age is going to print out Peter, and the person pointer.age is going to print out 30. So these two lines here are just equivalent to doing the dereferencing first. So you can see that I can get the same effect when I really do the dereferencing of the pointer, followed by getting the fields of that instance. Okay. Actually, I can also use the pointer to change the field names. So I can just say person pointer.name equals David. And after that, I can go to the person instance directly, and I can get the name of that person directly. So I can access the field directly after the amendment due to the use of a pointer. So let me see the result here. Yes, you can see that the person has changed his name to David. Okay. So this kind of changing field values is able to be achieved by the use of a pointer. Here we can also use the instance name to use the method. So for a person structure, I have a method called haveBirthday. So let me check this particular method for the person structure first. So here I have the method called haveBirthday. So I already make a method that accepts a pointer to a structure instance. So when I pass a certain pointer to this method, I'm able to just add the age of that person instance by 1, and I just print out that updated age after this action. Okay. So I can use the person.haveBirthday, or I can also use the pointer to use the method directly. So in Go language, I can just use the pointer to call the method corresponding to the structure instance. So you can see that I'm able to get the same result by adding the age. So let me try to play with it now. Here you can see that the age has turned to 31 after the first method call, And after the second method call due to a pointer, I can even change the age to another one. So it changes from 31 to 32 right here, okay. And of course the name is still David. I still get the same name of that person. Also, we can pass the pointer to the function. What does it mean by this sentence? Let us see this example. I've a function called isAdult here, okay. So I've made the function that accepts a pointer to a structure instance here. So isAdult is just using a person pointer to check whether that particular instance has the age that is larger than or equal to 18. Okay, so I can use this function to check whether that person the pointer is pointing at is really an adult or not. So let us see the result. Because David is already 30 years old here, I would say that David is really an adult. So let us see the result. Of course, it is already true because we can see that here David is already 30 years old. Okay, so I would be able to return true from this function. Okay. Now let us see another example of the pointer to a structure. So I can actually have nested structures and pointers. So what does it mean by the nesting shown here? Let us see this following example. I have a person instance called CEO, and the CEO is actually referring to the address of that person instance. So I have to go back to the person structure to allow this CEO to obtain the field values. So the person is already defined here. Okay, so that's why I can use this person structure directly to refer to this CEO variable, which is appointed to a person instance, and the person instance is just having these two field values. Okay, and I've also got a company instance, which is actually referring to the company structure shown below here. Okay, here I have a company structure and I have a name as the field. The name here refers to the name of the company, and I've also got the CEO field name, which is referring to a pointer to a person. So the second field here is storing a pointer rather than any other concrete variable. Okay, so you can see that for the company here, it is actually storing a company instance that has the name here and the CEO that is referring to the CEO pointer shown above. Okay, so this pointer called CEO will be linked to the company instance coming from the company structure. Okay, so I can just print out the CEO name of this company by referring to the CEO that is linked to the company instance. And I can also update the CEO by changing the name from Alice to Bob. Okay, and the age is also updated. And in order to use the update CEO function, I have to really pass the company instance address to this function. So let us see the update CEO function, which is here. This function will take a pointer to a company structure, and we just modify the CEO's information by using this function. So the update CEO would have the company pointer as the first parameter, and I have to use the new name as the second parameter, and the new age as the third parameter. Okay, so we can use two levels of dot notation to access the CEO particulars. What does it mean? When we have the company pointer, I can go to the CEO field of that company instance, and since this CEO field is actually storing the pointer to a person, which is actually the CEO, I can tell this CEO instance to really get the name from it. Okay, so I will be able to get the name, which is Alice first, and this Alice will be replaced by the new name here. So Alice will become Bob, and of course the age of 30 will become the age of 40 after the second instruction shown in the update CEO function. So after this amendment due to the update CEO function, I'm able to change the CEO particular. Okay, so let us see the result of running this part of the code. Okay, you can see that before I do the updating, the person that will be shown in the company.ceo instance will just be the person shown here. Okay, so the company field that is called CEO is just placing the pointer to the CEO instance shown here. Okay, and I can get the address of this person instance. Okay, so I can do the printing. Because CEO is really a pointer, the answer is also a pointer. Okay, and after the update CEO function is used, the CEO information will be changed. And you can see that since the CEO field is going to get the pointer to the person, it means that I'm able to show the pointer to the instance with name field as Bob and the age field as 40. Okay. So both results would refer to the address of the particular instance, because the CEO field here in the company structure is really referring to a person pointer. Okay, that's why we will have the pointer as the result. Okay, so we can see in this video that we can use a pointer to a structure to really locate the address of an instance made from a certain structure. Okay, and we can change the fields directly by using the pointer, which is equivalent to doing the dereferencing action. And we can also pass a pointer to a method so that I can use the pointer to a certain structure instance to act on a method directly. I can also pass a pointer to a structure instance to the function directly. And here I'm also able to apply nested structures and pointers to help me produce some kind of more complex structures by having a pointer to another instance. And then I can use the function that accepts a pointer to a structure instance to do some further amendment of the data in the original instance. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.